It's not always obvious why your 3D printer is misbehaving, especially if you built it yourself. It could be hardware, firmware, web interface, or just a simple user error. In this video, I'll show you what I had to go through and what I've learned while troubleshooting my little V0. So grab your favorite hot beverage, sit back and relax. You just might learn something useful. First, let's talk about how my issue started. The first occurrence was pretty uneventful. After shutting down the printer, it didn't boot up the next day. If I recall correctly, it started giving errors on the Klipper screen, and that's it. No boot after a power cycle. And now, let me take you on a journey that took me about half a year to find the solution to a problem that could have been solved in mere minutes. At first, I thought there was issues with USB connections, maybe a bad cable. Fiddling with the cables didn't lead me to a breakthrough. A less likely option, I thought, could be firmware. My Klipper installation was pretty old. After reinstalling it, guess what? Nothing changed. I was deeply puzzled. I started poking around with my trusty old multimeter. I probed the PSU, yes, that's a 350 watt power supply in a V0, and found out that it had been sending 30 volts to the electronics. Then checked the converter, 7 something volts. I thought, damn, I must have fried my electronics. So I ordered a brand new power supply. When it arrived, I thought maybe I should do a sanity check and probe the new unit to see its output voltage. And the results were interesting. It also showed 30 volts. I thought, that can't be right, and began suspecting my multimeter. Then I replaced its battery. That solved the problem. Now both power supplies were outputting voltage that was in spec. Then I checked the converter. Now it shows not enough voltage. Still trusting my old multimeter, I ordered a new DC to DC converter. When it arrived, I checked the voltage and it was also too low. After some thinking, I concluded that it must be the multimeter itself that's showing me wrong measurements. Guess it wasn't so trustworthy after all. So I ordered a new multimeter, making sure it was a quality unit. After it arrived, I checked the voltages and, to no one's surprise at this point, both power supplies were good and so were the converters. Alas, my struggles didn't end there. The printer still wasn't turning on. At that point, I was really fed up with trying to fix it and left it for months. Fast forward to now, I gave it another shot at fixing whatever was wrong with it. And this time I told myself I will stay committed and do whatever it takes to figure out what's wrong. After a lot of troubleshooting both different hardware configurations and reflashing firmware, about 11 hours to be exact, I started noticing a pattern. When the motherboard is connected to the Raspberry Pi, it freezes in the middle of the boot sequence. When the motherboard is disconnected from the Raspberry Pi, Klipper starts without fail. After disconnecting only the motherboard, it would boot up normally. Then, turning it off, connecting the motherboard back, it would turn on, but give MCU Raspberry Pi not connected error. After another power cycle, it would freeze during boot up again. To get to this point, I had already went through 2 power supplies, 2 DC to DC converters, 3 Raspberry Pis, 2 motherboards, 3 SD cards, a selection of micro USB cables. To put it bluntly, it was a long journey. After trying out every combination of hardware, I ruled out the possibility of having a bad component. Then, after scrolling through endless forums, I accidentally stumbled upon someone else suffering from the same oddly specific issue. Turns out, this is a bug in the Raspberry Pi's kernel that is only present in only a few particular models of their microcomputers. To be specific, it's present in Raspberry Pi 2B and 3B Plus models, and as far as I understand, it only shows up when connecting a Big Tree Tech SGA Mini E3 V3 motherboard. I think it may affect other distinct motherboard models in the same way. Maybe it's tied to the processor used on the motherboard, because there were revisions to the third version of the previously mentioned motherboard where different CPU models were used. Perhaps the USB chip on a Raspberry Pi is at fault. Whatever the main case may be, the solution to fix said bug turned out to be quite simple. Let's break it down. Step 1. Power down your 3D printer and unplug the motherboard. Step 2. Power on your 3D printer and SSH to the Raspberry Pi. Step 3. Open the config file. To do so, write cd/boot/firmware and press enter. This command opens the directory where your config file is. Then write sudo nano config.txt and press enter. This opens and lets you edit the config file. Make sure to add sudo, otherwise you'll get access denied error and won't be able to edit the file. Step 4. Editing the config file. You simply need to go down to the all section and write dt overlay equals dwc2. You might notice that the exact same line is in the cm5 section, but don't do anything to it, just leave it as is. Now press Ctrl and X on your keyboard at the same time, then press Y and then enter. Step 5. Exit the SSH interface and turn off your 3D printer. Plug in your motherboard and reboot. That's it. Now your 3D printer should work as intended. I'll leave the link to the discussion about this problem in the video description so you can look into it on your own time. Moreover, I'll write down the commands there that I explained as well, so you can simply copy and paste them onto your SSH window. How convenient! Though, if you are experiencing the same bug on a Raspberry Pi 5, editing the config file might not solve this bug. It might be a different USB issue. After all this trouble, here's what I learned. Don't use a cheap multimeter. If you're into building custom 3D printers, you sure have the budget to also get quality tools. Using a high quality multimeter from the get-go would have saved me a lot of time, money, and especially sanity. It would have prevented me from going down unrelated rabbit holes trying to chase down an electrical fault that wasn't even there. Another nugget of wisdom I can give you is to always check that the power supply is set properly. You'd be amazed at the amount of issues this could arise. Some of the most common ones are USB device flakiness, printer stopping mid-print, host MCU brownouts, and many other similar problems. So don't skimp on power delivery. Remember, if your 3D printer's electronics are the brain, then your power supply is the heart. You wouldn't want a heart that sometimes forgets to beat. Also, as a bonus, a beefier power supply could give you just that extra little bit of acceleration for those high-speed benchies. I want to thank you from the bottom of my heart for watching. It was very fun making this video. I learned a lot, not only about filmmaking, but about myself as well. It took me quite a while to make this video, and I'm sure you can tell that I'm very new to this. I'm really looking forward to seeing you in the next one.